Okay guys, so it was my birthday last weekend and I got this cool new truck. Check it out. There it is, getting dropped off at my house. Isn't it sweet? Anyway, my dad says that before I can drive it, the truck needs to pass emissions testing. In Texas, a vehicle will fail the test if there's an excessive amount of hydrocarbon, carbon monoxide, or nitrogen oxides. Emission tests measure the gas coming out of the tailpipe. In chemistry, we just learned about ionic compounds, which are mostly solids. So, what are the gases coming out of my truck made of? Well, turns out the emissions coming from my new ride are called covalent compounds. Remember where nonmetals are? All those guys on the right side of the periodic table. Covalent compounds share electrons to achieve an octet. Remember, all atoms are wannabes. They all want to be just like the noble gases. That's the goal. You should also know that there are 3 types of covalent bonds. Triple bonds are shorter and stronger than double bonds, which are shorter and stronger than single bonds. How do I remember that? Well, more is better, right? Something else that's interesting about covalent bonding, atoms don't combine in specific ratios like they do when ionic bonding occurs. Nonmetals can come together in many different ways. To tell covalent compounds apart, we put prefixes in front of each atom. Here's what I mean. These 2 compounds have different names. To help us keep these covalent compounds straight, we use prefixes. You've seen prefixes before, probably in geometry. Think pentagon, hexagon. You learned about these 5- and 6-sided shapes forever ago. And there's good news, guys. There are basically 3 steps when it comes to naming covalent compounds. Let's look at the first compound. In order to figure out what it's called, write the name of the first element. Phosphorus. There's only one phosphorus. When you have only one of the first element, you don't need to write the prefix mono in front of it. It's kind of understood that it just means one. There are 3 fluorine atoms, so we will use the prefix tri to represent these 3 atoms. Then you add "ide" to the end. For the second compound, we will need to use prefixes for both elements. There are 2 phosphorus atoms and 4 fluorine atoms. We will use the prefixes di and tetra to represent these numbers. So our compound is diphosphorus tetrafluoride. So what about the emissions coming from my sweet ride? One test will measure how much carbon monoxide and carbon dioxide are coming from the tailpipe. So what does the chemical formula look like? I know there's carbon and an oxygen, but which one goes first? Well, just like when you're reading a book from left to right, the same goes here. When you're writing a chemical formula, list the element farthest left on the periodic table first. Here is carbon. It is to the left of oxygen, so carbon goes first in the chemical formula. Okay, so there is no prefix at the beginning of the name. Therefore, we can assume that there is only one carbon in our chemical formula. Mono means one. That means that there is one oxygen in our chemical formula. The prefix mono is only used with oxygen. We wouldn't call this monocarbon monoxide. It's just carbon monoxide. Carbon dioxide has 2 oxygens because di means 2. Oh man, I cannot wait till I get to drive my new truck. But I can't right now because, unfortunately, it failed the emissions test. Looks like I'm going to need a new catalytic converter. What's a catalytic converter, you ask? It's a device inside your car's exhaust system used to remove harmful pollutants. It contains transition metals like platinum, rhodium, and palladium. Hey, did you know that transition metals form ionic bonds too? There are a few things you need to know about writing and naming compounds containing these metals. Check it out. These transition metals are in the center of the table, but we chose to ignore them when we first started learning about ionic bonding. These elements are a little tricky because they can have more than one oxidation number. Remember, all metals form positively charged ions and lose electrons in an ionic bond. To determine the charge of the cation, look at the charge of the anion, which for nonmetals never changes. Here's what I mean. Here are two transition metal compounds containing platinum and chlorine. They have different names because platinum can have more than one charge. The chloride anion will always have a -1 charge. The main group elements aren't crazy like these metals. In the first compound, there are two chloride ions, each with a negative charge. To determine the charge of the cation and the name of the compound, all you have to remember how to do is add. Easy, right? For the compound to have a net charge of 0, there must be two positive charges to cancel out the two negative charges. For the compound to have a net charge of 0, there must be two positive charges to cancel out the two negative charges. So, that means the platinum ion must have a +2 charge. Yeah, so what? Well, the name of the compound is platinum 2 chloride. Notice the Roman numeral 2 in parentheses. The transition metals are the only compounds that have Roman numerals in their name. Can you guess the name of this second compound? You got it. Platinum 4 chloride. The charge on the platinum cation is +4 this time to cancel out the 4 negative charges from the chloride anions. So, there you have it. Now you know a little bit more about covalent compounds and ionic compounds containing transition metals. Keep an eye out for me because I'll be driving that awesome truck to school soon. Better get the windshield fixed too, huh? Bye guys, we'll see you next time.